So this is the portion of our session, which I always feel like is the funnest part, because we get to put people on the hot seat. I'm just playing. Don't feel that don't feel that kind of pressure too much. But obviously, we had a lot to unpack from that session, right? So we'd like to just be able to have the opportunity to kind of go through some things, and if y'all are okay with this, I would actually like to start off with a question that we've got from Zoom. Because our Zoom audience has also been sending in some fantastic questions as well. So I actually just want to start off SJ, who's actually asked. It's a very good contextual question as well. And the question was, COVID has taught us that fresh air and frequent air changes is important. How do you think the pandemic has changed, our attitudes towards design in respect to well-sealed buildings, right? Because a lot of people might say, oh, if all of this, the air is kind of stuck in there and it gets all stale, then how are we going to make sure that we have healthy oxygen within our buildings? So how does the panel, would anyone from the panel like to address that question? Thank you very much, SJ.
Yeah, I'm happy to have a go at that one. So that's actually what I like about the Passive House standard, is that it is a health and comfort first standard. The people who designed the standard 30 years ago realized that you need fresh air to be healthy. And what we're seeing in the hotel quarantine system is that people have been quarantined in buildings that have the wrong kind of air pressure dynamics, because it's pressure inward into the building and mixing within the spaces. Whereas if you get that air pressure design right, you're basically extracting air from all of those spaces and delivering it fresh. It's a little bit different in a house because you're not trying to isolate people from room to room. But in a house scenario, people are starting to realize that, indoor air quality is important, and the way the Passive House delivers that is you essentially have fresh air delivered to each room, and then extracted from the wet areas. So it's a bit like the lungs of the house, a heat recovery ventilation system. And in order to do it in such a way that is not leaking energy, that's why you have the technology of heat recovery ventilation. So yeah, I think this whole situation is opening people's eyes up to the importance of ventilation. And like I said, one of my slogans, seal it tight and ventilate it right.
That's a fantastic point, because just because we are creating better, if we're to, being able to, once again, to the theme of this, net zero ready homes, healthy, comfortable, we need to, that does, as we're going through, does include measures of energy efficiency. And then that also helps, of course, with like a climate change kind of scenario. But to make sure that we're addressing all the health aspects as well, needs to make sure that they're in conjunction with the right types of materials, the right types of layers and design. We do have, James has a response to that question as well.
We've just posted a little thing in the chat. I'm not sure you can see that. I'm not sure if everyone can see that on the screen or not, but it's just a little infographic that shows the optimum zone, and a few of us have alluded to that amongst relative humidity. Yeah, that's it. So between 40 to 60%, and it's not necessarily an exact, but if you're aiming towards that, mixed in with the heat recovery ventilation systems that have also got filters to purify the air and HEPA filters, you can go to any lengths you like, really. But that's been scientifically proven to actually, bacterias, molds, funguses, they all die out around that optimum zone of relative humidity. So using all of this technology and systems together really helps to deliver that. So it's actually, it's exciting to see maybe if COVID drives people towards this a bit quicker, maybe.
Thanks heaps for that, James. Do you have a question from our in-person?
So it's for James. You didn't mention that, but can you speak about the process of fabrication of the live panel and how it's actually really using some good components and coming to the carbon print of Australia, potentially?
So yeah, the moment the material is all made in Europe in rotation crops. So the trees are grown in small sections. They go from tiny saplings all the way through to mature age trees, and then it's on the rotation. So when they reach mature age, they get chopped down, and the logs get turned into house framing or other useful timber components. Then all the waste and the offcuts from that get turned into wood fiber product. So in its production in Europe, it's actually carbon negative. And for every 1 ton of material that is made, it stores 1.2 tons of carbon. Now, obviously, shipping across to this side of the world is not necessarily carbon negative, but the sheer volume that the container ships bring, and the fact that the material is a natural ecological material that's non-toxic, non-harmful, is primarily spruce timber. So there's no harmful off-gassing or VOCs. And it's all obviously tested to meet and comply with those safe levels of performance. And then the embodied energy within the house and the performance of the house and the low energy consumption for the life of the building go towards that entire life cycle of the building to have a low embodied energy.
Hope that we can actually produce this kind of material in Australia, because there is a lot of forest and a lot of waste from the industry.
Yeah, I knew someone was going to ask that. So I can't go into too much detail at the moment, but yes, there is some very serious conversations taking place for us to be able to manufacture here in Australia.
Yeah, I think there's obviously a lot of opportunities in regards to manufacturing here in Australia. We just need to make sure that we get a lot of that quite right. But I actually wanted to, just off of the back of that, I want to bring in Scott and also Craig for that. Well, one, Scott, in terms of the aspects of healthy materials, do you think, natural materials, do you think there's a lot of thirst from like the clientele that you're working with? Are they coming to you with the aspect of health and well-being considerations? Is it embodied carbon, or do you think that there's still a lot of there's a big gap that we still need to bridge in regards to those kind of conversations?
Yeah, I think there's probably still a fairly big bridge. A lot of people that come to straw bale, or it's not so much they're being talked into it, it's because and same with any of the natural materials, it's not so much they've been talked into it and recommended it, it's probably more that they've known about it and they've done the research already for a lot of the work that we get. I think, yes, we're always continually trying to, get out there and with the health benefits like we are tonight. But I think there's still a long way that to go with that.
And this is kind of where I wanted to go in between yourself and Craig as well, because we also had a question from the audience from Bobak, where the question was around, prefabricated materials, and does that also play a part in the net zero ready high performance homes? So with the prefabrication of materials, do you see there's a part for natural materials to play a part in that? And then if you could address that, because that makes sure that there's standard sizes that people can use, like the Dura panel or Life panels. But at the same time, after you address that one, Scott, I was hoping to bring in Craig from a manufacturing kind of standpoint. What does it, you've been part of an Australian organization that is manufacturing here. So is there, what's the opportunity to embed more manufacturing, like what are the opportunities in the manufacturing space for high performance buildings? If we can kind of go back between that.
Yep. There is prefab happening in the natural building industry and is being developed. So there's 2 companies in New South Wales that are doing straw bale prefab, Huff and Puff and Viva panels, and they ship around the place. It's still being developed. We've tinkered a little bit with it, but there hasn't quite been the market there for us yet. And in regards to hemp, WA have probably led the way, a lot of the companies over there, and they're starting to do some hemp blocks, as well as some prefab panels over there too. But obviously with the shipping, it's prohibitive, and it's possibly there's definitely potential for that.
High performing membranes is not only thinking about the basics, which is the breathability, toughness, etc., but also now the non-combustibility is a big factor, and it's on everyone's minds these days. What we strive to do is to incorporate all of these factors into the one membrane, and it's quite a difficult process. Traditionally, a non-combustible membrane was actually just a sheet metal, a metal sheet, because steel doesn't burn. But it's what I'm proud of our company is that we strive to get all of these factors in. So fire and safety, health and safety, air barriers, the whole passive building, and incorporate that all into the one system. So yeah.
Yep. And do you see that there's manufacturing opportunities for other sort of products in Australia as well?
Yeah. Rigid air barriers is another area where I think Australian manufacturing can really have a good look at, because there's a lot of opportunities there. To be innovative and to get the right product for the right situation.
And potentially that's something that even as James kind of pointed out with wood fiberboard, there's an opportunity to have that rigid sort of layer with being able to make sure that we're keeping a high level of protection against vapor and moisture and stuff like that. We had another question from the Zoom, if you don't mind me going to that, our community there. There's a question from Jake asking whether or not there's a possibility to have a low air change per hour, so a better level of air tightness, so a lower figure on those lower door tests, without actually utilizing mechanical ventilation. Like, is there a sweet spot of when do we need to bring in when can we just let the building breathe naturally and still have a healthy building, but at the same time, what is that click over for needing that assisted ventilation? Shall we throw that over to you, Brett? And James, I'd like to bring you in after Brett's response as well.
Yeah, look, that's a good question. I think heat recovery ventilation is certainly very new in South Australia, and people are a little bit nervous about building houses with heat recovery ventilation because it feels like perhaps too tightly sealed, or it feels too expensive. So I do have this conversation a lot around, when do you have to use heat recovery ventilation systems? I guess the thing about the Passive House Standard is it's kind of proven and tested, and so the idea is that you get to that air tightness and then you ventilate and then you get a healthy building. Anything that's not that, you're sort of going into a slightly vague area, so that's the first thing to say. I think if you're going to be under around 5 air changes per hour, you really need to be careful of the indoor air quality, because you're going to risk having high CO2 levels, for example, inside, and indoor air pollutants can build up. But the thing about the Passive House Standard is it recognises that you need 30 cubic metres of air per person per hour, so it's a bit like a bedroom full of air, and that's what the heat recovery ventilation systems are designed to deliver. If you're not using a ventilation system like that to deliver that, you're not really going to get it through building leakage. So then you need to use, doors and windows to ventilate. But the problem with that is you've essentially then got a hole in the building and you're also leaking energy. So what I say to my clients is, if you want an energy efficient building, you've sort of got to make a choice of having something that runs a bit automatically with heat recovery ventilation, or you need to sail the building and open and close the windows consciously. And one way to monitor the indoor air quality is to get an air quality monitor. So that's what I say to my clients who are sort of under 5 air changes per hour, is you really should get an air quality monitor. And when my clients have done that, they've found that if they leave the windows closed overnight, the CO2 levels spike and go into a place that's not healthy. So they have to leave the windows open. And that means instead of having a temperature between 20 and 25, or even 18 and 25, the temperature in the bedrooms goes down to sort of 15 or 14, and it's whether or not you're prepared to have that level of thermal fluctuation.
Yeah, and James, I'm pretty sure when people are looking at some houses that are actually utilizing life panels, they might actually be thinking, oh, you're actually just creating a full esky box. Holy crap! What is going on with these this product that's like lining the whole the timber frames and things of that nature, both on the roof and in the walls. So could you let us in on how you've been also mediating a little bit of, do we go very well sealed, and also how do we make sure the building breathes with the various building membrane design?
Yeah, firstly to say that there's a bit of a misunderstanding around Passive House, which is perfectly understandable when you don't spend any time studying it, but this kind of idea that you have to live in a fully sealed box and you've got 100% never open windows and doors, that's there's elements of that are true, but like I said at the start of my presentation there, it's it's not black and white, and everything that everyone said tonight is based around good common sense, good design, and using the materials to absorb the heat, buffer the heat, you know, keep the air in, and it's all of that, and you have to keep repeating that. And so there are elements in some climate zones where, using the WUFI analysis, you can actually suggest that what's called a night purge, where opening the windows and cross ventilation from a natural perspective can help the building. But it has to be considered in the context of the climate zone, the position like it is on the land, and all of these factors. So the heat recovery ventilation is a great thing to use, because it just helps to be more controlled, and you're not just reliant upon, you know, extreme temperatures at night time or letting the air leak out. And it is very much a monitoring process. And so I recommend those, the air quality machines, and also like a little relative humidity thermometer. And it shows you over a 24-hour period the high relative humidity and the low, and also the high degrees centigrade and the low degrees centigrade. And particularly that's important because if you, let's say, a south-facing, a southwest corner of a building, if that's a bedroom, and the internal surface of that wall drops to around 12.6 degrees and the relative humidity is 60%, that's optimum for mold growth. So, and you can even get that in a passive house if it's not designed properly, considered properly, in good materials. So yeah, just goes again to prove that none of this is black and white, and it's good to utilize all of these experts and the materials and the technologies that are out there as a system.
Thanks for that, James. Do we have a question, another question from our in-house audience? If not, I'm going to push it right back to Zoom.
I work for a modular builder, and so one of our biggest challenges is weight in transport. So other than like air tightness, what are some lightweight solutions or products that the panel might suggest to incorporate
Fantastic.
into the building to make it more high performing?
Yeah, right on. Thank you very much. Any thoughts on lightweight sort of construction methodologies, Craig?
Yeah. Touching back on before about optimum places, or I suppose, or constructions, the Queenslander comes to mind. Queenslanders, back before air conditioning was sort of invented, I suppose, and used widely, the internal lining on a Queenslander was actually non-existent. Actually, if lightweight building methods are employed, then the right membrane can be light as well. So you don't have to have heavy building methods to control things. I firmly believe the more we get towards a man-made product, the less I suppose the less user-friendly it is, I suppose. You know, the more plastic, the more metal, the more it's harder to control. Just like your straw building methods, the more natural bricks, they tend to be more closer to a living organism than man-made stuff.
And Brett, you've kind of sort of dabbled in prefab kind of bits and pieces, and I'm pretty sure there's always this question of the, I mean, not only just weight in prefab, but then also thickness of walls that comes into equation on cost. So how do you kind of wrestle with that in terms of building up a very good building fabric?
Yeah, look, I think the obvious answer is high performance foams. So, you know, there's quite a lot of high performance foams on the market. But to be honest, my personal opinion is I prefer to go towards the more natural materials. So it's interesting that we've got a bit of a panel here of natural materials. So
Panel this
yeah, so look, I think the high performance foams are going to be obvious because they're light and they're relatively thin for the R value performance that you get out of them. But I was very excited to see the wood fibre in this forum because I wanted to use wood fibre in buildings here for years. So look, I don't know. It depends what your market is. I think if you've got a market that's, say, just into cost and performance, then maybe you go with the high performance solutions like the foams and the membranes. But I do think if you've got a market that's into health and well-being and sustainability, then it's really important to consider some of the more ecological products like the wood fibre or paper fibre in combination with some membranes.
Yeah, and I wanted to bring you in on that as well, Scott, because obviously there's a lot of development in these natural materials, once again, to make a manufactured product rather than in situ.
Yeah. So, like I'd mentioned before, there's the straw panel, prefab straw panels. They're probably not as light as you probably would prefer, but some of those, they're about 200 mil thick, and they can come either pre-rendered or ready to be clad. And basically, they use the crane truck that they arrive on and just basically put those in situ on the on site. The other system is unrendered. Basically, it's the wall frame and the straw bales all in one, and they're light enough that they can just be stood up by two people and put into place. And basically, they're straw bales in a ply box. And those, again, both of those have been developed in New South Wales, and there's been a couple of the Huff and Puff panels that have been installed in South Australia, one in KI, and one up in Harrogate that I was involved in up there. So there is those possibilities, and it'd not be nice to bring some of that development closer to South Australia as well. So yeah, as there's a market, we'd probably start looking into it as a bit more seriously as well.
Yeah, and I'd like to bring in James in on that. If you could just turn that one off, Scott. James, could you give us also an idea? If it is about weight, because that goes to how much you can load a truck, how much it costs. Could you give us an idea also of, are wood fiber panels or life panels actually easy to transport? Are they lightweight, or is it a little bit more of a heavy, denser sort of product as well?
Sure. Well, it's a lightweight material. I think each panel is just around 1.1 square meters and weighs around 10 kilograms. So you can, as one tradesperson, you can lift two panels. But the issue that I face at the moment, which is an interesting one, is the cost of freight from our warehouse in northern New South Wales. And it varies. Like, we have people in Tasmania say, oh gosh, that's a really amazing price. And we get charged, more than that from Melbourne to Tasmania. But then at the same time, you get the other end where it's like, oh man, that's just cost prohibitive. Like $3,000-4,000 for a full semi-trailer or a B double, because it's large volume. It's not, you can't just pack it down into small packages. So it's that's one of the reasons why it's worth. And I'm excited to start the process of looking at manufacturing in Australia, because it'll mean that we're able to get rid of that kind of high cost and make it more attainable. Yeah.
There's always this bit around, yes, even though they are old materials, natural materials, to kind of get them to a market kind of standpoint, there also needs to kind of be some of like that demand, which is where a lot of you in the industry kind of come into play as well. So if you could figure that out for us, that'd be fantastic, sir. The reason why I had to hold the mic is that we did have a question on the Zoom, which I do have to finish us out on. So very sorry about that. But I think this goes through a lot of people's mind when we're talking about high performance homes, right? So a lot of it sounds like it's always new build. So the person that is posing this question or wants a response to this kind of idea is Mauricio, and he asks, because a lot of like the high performance building sounds new, what about retrofits? You know, can we apply sort of like the same approach, materials to existing houses, because obviously there's a building stock that we need to improve. So that's one of the questions. Can we actually do that in a retrofit manner? But at the same time, is it more cost prohibitive to retrofit rather than build a new when you're thinking of, you know, thinking about energy efficiency, thermal comfort, and health?
Probably just to start there, I guess, yes, it's all possible. We have retrofitted in straw bale before, and you could probably do it in hemp as well, around an old transportable home. Problem with that is you just have to, it's more engineering to go into that. So we had to create a bit of a system around that building, and then we extended that building out. So it was a bit of a wrap the old building in straw and then extend on it. So yes, it's possible, and with natural renders that can pretty much go on anything and help. Well, it could act as a membrane to help seal the building. You can also use sort of, probably to a lesser extent, use a hemp and rendered system, and that'll give us a little bit of a insulative value, but yeah, not a massive amount, and then probably to the synthetic.
And James was about to come in as well. So
with the wood fibre, it's almost 100 years of proven technology in Europe, and the idea of it is that it's good for new build, but also for retrofit, and retrofit internally and retrofit externally. And obviously there's pluses and minuses to that. You lose a bit of room space. You have to extend all of your external downpipes, taps, whatever. But Passive House also have part of their certification called Enefit. So you can actually apply some of the Passive House principles to a retrofit to achieve a low energy house. But it does cost more, undoubtedly, because it's just the nature of what it is to do retrofit and undo work to then start with new elements. And I think that's the painful part for people, that, you know, particularly I get asked this a lot on projects where they've got, say, an old Queenslander, got the cladding on the outside, you know, 80 years of thick paint, and they go, there's no sarkings, we want to insulate. And then you have the discussion around, well, you can't necessarily just insulate, because then you're going to create other problems if you don't address the moisture behaviour. But they go, oh, but we don't want to pull the cladding off. And so there's that kind of mindset as well, that to really invest into a retrofit, you would have to have that mindset of, we have to go through some pain of undoing some good work to then, you know, start doing better work to end up with a better result. So it's worth it in the end.
Thanks heaps for that perspective, James. And Craig, Brett, could you give us any thoughts on sort of the new build versus retrofit? How do we actually start to wrestle with this?
I tend to agree with retrofits, but it does require paring down to the basic structure and basically starting again. Especially with membranes. There is no real quick fix. The whole system needs to be addressed, which means stripping it down. A lot of things like a roof are hard to reuse, especially like tin. Tiles, no problem, but yeah, we would always recommend a a full strip down. Yeah.
Yeah. And what say you on this one, Brett?
Look, I think it's really important for us to figure out how to retrofit existing buildings because that's the majority of our building stock. So I think it's imperative that we find ways. There's a lot of embodied energy in the existing buildings. And like James mentioned, the Passive House Standard has, got its head around that. So there's an NFIT approach to that with some specific differences to the new build. And look, it can definitely be done. I mean, the question is how far do we take it? It might be very expensive to turn an existing building or an existing house into a Passive House certified or NFIT building, but you can certainly get close to that. So it's a matter of what to address first. Address drafts, for example, was an obvious one. Then address maybe insulation, then address windows, etc. There is one building I know one house in South Australia where the approach was it's a brick veneer house, and the approach was, well, the best way to actually retrofit that in a way that's going to be high performance is to pull the bricks off the outside, because the bricks are the cladding in that case. And rather than destroy the plasterboard and all the internal linings and all the internal fittings, the decision was to take all the bricks off and then insulate well from the outside. You've got a good solid timber frame, and then put a membrane on the outside of the frame and then reclad it with whatever you want to reclad it with. So that kind of thing is definitely possible.
Yep. And that's why a lot of these questions, these approaches require good teamwork, right? I mean, it's not just for air tightness, making sure that you're connecting with the right types of builders, designers, and also manufacturers. That is what is able to help create a holistic approach. So I just want to, so could you all please join me in just thanking our panel for fielding our questions and also giving us some insight into net zero energy ready and high performance homes. Also want to give a big shout out to the ASBN sponsors, because that's also a big reason why we're able to pull these types of events together, these kind of gatherings. And in conjunction with that, once again, just want to give a good shout out to the South Australian government for helping us put on this this event, which is the Department of Energy and Mining, especially in the energy efficiency. Support comes in lots of different areas, and we appreciate anyone who helps enable us to have these kind of conversations, not just within South Australia, but obviously beyond. And lastly, ASBN team. The team efforts not only in high performance buildings, but team effort always in delivering these sorts of events. So make sure that, Zoom, you can only do it virtually, but hand claps for the ASBN team. Renee, Sarah, and Carrie, thank you so much. Y'all are the wonderful sauce that makes this such a fantastic experience. Anyway, without further ado, thank you for sticking with us. I hope you'll have a fantastic night.